All right, so let's talk about the last page of the guided notes. So remember when we were talking about multiplying and dividing, we talked about the fact that there are times you can factor out a -1 if you have two factors that look exactly the same, but all the signs are switched. Same thing happens here when you're trying to find an LCD with the pool method. So if you look at the problem that I've got right here, if I go to factor this first denominator, I have an x minus 3, and I can't factor that anymore. If I look at the next denominator, though, it's 3 minus x, which is almost exactly the same as x minus 3, except the signs are reversed. So if I want to make those match, instead of treating those as two separate factors, I'm going to pull a -1 out of it. Let me change colors so it's clear it's a different denominator. I'm going to factor a -1 out of it, and that would make that an x minus 3. And then I'm going to factor the x squared minus 9, which is x minus 3 times x plus 3. Now, when I go to build the pool, that -1, you can leave it as part of the factors in the bottom. You can use it to change the entire sign of the fraction. It really depends on you. I'm going to use this and basically use it to change this plus to a minus. So when I write it in the step below, it's going to be a minus. Because remember, if you multiply the top or the bottom of a fraction by a negative, it changes the sign of the whole fraction. So when I go to build the pool, I need an x minus 3 from the first denominator. So I toss it in. Go to the second denominator. I've already taken care of the -1 because it's changing the sign of another fraction. So now I need an x minus 3, which I already have right here. And then I go to the third denominator, and I need an x minus 3 and an x plus 3. So I'll toss in the x plus 3. Now I'm going to go through and adjust all the numerators. So this was 3 over, it had an x minus 3, but now it's missing the x plus 3, so I have to multiply the top and bottom by that. The second fraction is now subtracted because of the -1 we pulled out. It had a 6 on top, and it had x minus 3 on the bottom to start, and it's missing the x plus 3 as well. So I multiply the top and bottom by that. And then I go to my third fraction, which had an x on top, and it already had the x minus 3 and x plus 3 on the bottom. Let me write that in. X minus 3, x plus 3, which is already the common denominator, so I don't have to do anything with that. Now, when I go to combine these, my denominator is going to be x minus 3 times x plus 3, which is x squared minus 9. The top, it's kind of nice because there's subtraction going on here to go ahead and write this out the way it appears and then do the distribution. The reason I like to do that is because that minus that was in front of the second fraction can sometimes get lost, and you want to make sure it actually gets to everything that it's supposed to. All right, so let's combine like terms. You see 3x minus 6x plus x is -2x, and then 9 minus 18 is -9, and this is over x squared minus 9. So that would be your final result. So let's talk about the problem at the bottom with complex fractions. Now, complex fractions, remember, are stacked fractions. So whenever you have a fraction inside of a fraction, the big fraction bar, that means this one right here, is like a grouping symbol. So basically, you have to put together anything that's on top or anything that's on bottom first before you do that big division sign. So we want to do 4 minus 6 over x minus 2. So we need a common denominator between those. Currently, the 4 is over 1, and the 6 is over x minus 2. Now, this is an easy common denominator to get because it's between 1 and x minus 2. So the common denominator there is x minus 2. So that would be then 4 times x minus 2 over x minus 2, and then minus 6 over x minus 2. And then when I combine, that would be 4x minus 8 minus 6, which is 4x minus 14, all over x minus 2. Now I'm going to do the exact same process on the bottom. So this is x plus 3, and this is minus 1 over 1. I need a common denominator between those. That would be x plus 3. So that would be x plus 3 and x plus 3 on the bottom. And then I need to combine the fractions. Now again, this is the thing I was talking about before, where you're subtracting, you have to be super careful. Denominator is going to be the same. 5 minus x plus 3. So 5 minus x, the minus x is going to be there. And then 5 minus 3, so it's going to be plus 2. Now I'm ready to rewrite this complex fraction as a division problem like we did in class the other day. So this would be 4x minus 14, same. Switch the division to a multiplication, and then flip. Like that. Now notice, nothing in here is, I could factor some stuff. 4x minus 14 would be 2 times 2x minus 7. But nothing in here is going to cancel or simplify. So that means basically I'm going to go ahead, and since the top and bottom, when I multiply them out, the quadratic, I'm going to go ahead and knock those out. So it'd be 12 minus 2x minus 42 over negative x squared. Let's see, 2x plus 4x minus 4. And that would be your final answer.